Unit 1 and Unit 2 questions by me, Gisela Maldonado. To begin, we'll be learning 3 strategies to add 79 plus 43. The first strategy we have is by first adding 70 and 40, and this would equal to 110. Then we would add 9 plus 3, which then would equal to 12. Then we would add 110 plus 12, which would give us a total of 122. A second strategy to add this would be 60 plus 40, which would give us 100. Next, we would add the remainder 19 plus 3, which would give us 22. Adding 100 plus 22 would give us 122 again. For the third strategy, we would use the algorithm method. So we would first add 79 and 43, and first add 9 plus 3, which would give us 12. We would carry the 1 and add 1 plus 7 plus 4, which would give us 12. Our answer again would be 122. Next, we will be looking at converting to different bases. So first we're going to take 9 to base 10 and we're going to convert it to base 5. So first we take 9 to base 10 and we put place values against them. So we put 9 over 10 1 and 2 over 10 0. 10 0 is 1 and 10 1 is 10. So we look at it as 9 groups of 10 and 2 groups of 1, which in total would be this equals 92. And now we have to ask ourselves, how many groups of 25 are in 92? Before we are able to answer that question though, we have to ask ourselves, why 25? Well, you have to put in the place values of base 5. So we have 5 to the 0 power, 5 to the first power, 5 to the second power. That's why we ask ourselves how many groups of 25 are in 92. And in this case, it would be 3. So 92 minus 75 would equal 17. There are 3 groups of 5 and 17, which gives us the remainder of 2, which would go into the 5 to the 0 power. So our total answer would be 332 base 5. Next we have adding and subtracting in different bases. So here we're going to add 2 3 base 5 plus 3 4 base 5. We're going to do a similar process as we've done before. We're going to put each number into their place value. So here we have 2 groups of 5 and 3 groups of 1. So that would mean we have 10 plus 3, which is 13. Similarly, we're going to put 3 4 base 5 into its categories. So here we have 3 groups of 5 and we have 4 singles. So in total we have 15 plus 4, which equals 19. So now we are going to add 13 plus 19, and that gets us a total of 32. Our last step now would be to write out the bases. So we have 5 0, 5 to the 1, and 5 to the second power. And as we know, that means 25, 5, and 1. So we ask ourselves, how many groups of 25 are in 32? There is one group of 25, and 32 minus 25 equals 7. So now we ask ourselves how many groups of 5 are in 7, and we have 1. And the remainder would be 2. So our answer would be 1, 1, 2 to the 5th power. Subtracting in different bases is a very similar process. So first we're going to do 1, 1, 0, 0, 1 base 2 minus 1, 1 base 2. Up here would be to put each number into its corresponding group. So here we have 1 in the 2 to the 4th power, 1 in the 2 to the 3rd power, 0 in the 2 to the 2nd, 0 in the 2 to the 1st, and 1 to the 2 to the 0. Now, what it really means is there is one group of 16, one group of 8, 0 groups of 4, 0 groups of 2, and 1 group of 1. So in total we would get 25. We would do the same process for 1, 1 base 2. Here we would put one group of 4, one group of 2, and one group of 1, which would total to 5. Now we would subtract 25 minus 5 and get 20. Now we would ask ourselves how many groups of 16 go into 20, which would be 1. 20 minus 16 would then leave us with 4. And 8 cannot go into 4, so there would be 0 groups of 8. And then there would be 1 group of 4. And then the remainder spots would be filled with zeros. So our total answer would be 10100 base 2. Now we are going to use 3 strategies to find the greatest common factor. So the first strategy we're going to use is the Euclidean method. We are going to find the GCF of 36 and 84. So first we would put 84 at the first part of our equation and would equal to 36, and we would ask ourselves how many multiples of 36 can fit into 84, and that would be 2. 36 times 2 equals 72. So now we would say 84 minus 72 equals 12. So we would put that remainder at the end of our equation. Now we would take 36 and move that to the front. And then we would take 12 and move it up as well. And now we would ask ourselves, how many multiples of 12 fit into 36? The answer would be 3. And now we would have 0 as a remainder. 12 would be the GCF because it is the last non-zero number. For the second method, we would be using ladder method. So here we would put 36 and 84 and ask ourselves, what goes into these two numbers? I chose 3. So then we would put as the remainders in the other box 12 and 28. We would see if another number can goes into this, and I chose 4. Then we would have the remainders of 3 and 7. There is no other number that can go into these numbers, so then we would take 3 times 4 and we would get 12, which would then be the GCF. The last method to find the greatest common factor would be to use the factor method. Here we would write all the factors of 36 and all the factors of 84. After writing out all the factors, we would then see which one is the common and is the greatest, and we have 12. The answer again would be 12 for the GCF. Next, we'll be looking at least common multiple for 16 and 24. First, we will do a factor tree of 16, and then we would do a factory tree for 24. After we do this, we will list out the factors By listing out the factors, we can see that there are multiple groups of 2. We can group these vertically, and these groups would now just count for 1, 2. So we would then have 2 times 2 times 2 times 2 times 3. The first 3 2's come from the 3 groups of 2. The last 2 comes from its own, and the 3 comes from its own. Then we would multiply all these numbers, and I multiplied 16 times 3 and I got the answer of 48. This is our LCM. Another way to do this problem would be to write out the multiples of 16 and 24. After writing them out, we would see which one is the least common multiple, and here we got 48 again. Now we will be doing the least common multiple for 12 and 30. Again, we will be doing a factor tree and then listing out the factors and grouping any vertical similar factors. So in this case, we have one group of 2 and one group of 3. So we would multiply 2 times 2 times 3 times 5. After multiplying these, we would get 60 as the least common multiple. Now we will use 12 and 30 and list out their multiples and compare and see which one is the least common. After listing out all the multiples, we would take a look and see that 60 is the least common. We'll be doing integer addition and subtraction using charge chips. Now we would do -7 minus -5. So before we do this problem, we have to know that the blue is positive and the red is negative. So here we have to start with -7. So we draw -7 circles, and we're going to take away -5 circles. So then we would cross out 5 of the negative circles, and that would give us a remainder of 2 negative circles. So our answer would be -2. As for -7 plus 5, we would draw out -7 circles. We do not have 5 positive circles to take away, so we have to consider adding a positive and a negative, which would be a non-zero pair. So here we would add 5 positive circles in order to do this problem. These would then cancel out 5 negative circles and would be a remainder of -2. Now we'll be multiplying 3 over 4 times 5 over 6 using fraction operations and the area model. So first we would draw out our area model. We would have 4 columns for the 4 denominator, and then we would have 6 columns for the 6 in the denominator place in the second fraction. So depending on the denominator is how many columns you will create in your area model. After creating your area model, you will take a look at the numerator. So for the 1/4, we have 3 of them that we need to fill across. So this is what we're doing now. Then we take a look at the numerator 4 over 6, which is 5. We now do all the way down. For our answer, the denominator will be the total number of boxes created. So in this case, we have 24. And for the numerator will be the double shaded boxes. And by counting them, we have a total of 15. Now this can be reduced by dividing both the numerator and denominator by 3. So we would get 5 over 7 as the final answer. Next we'll be multiplying using scientific notation. So first we're going to take a look at 4.7 times 8.9. And by multiplying this, we get 41.83. Now we're going to take a look at -1 and -5. Those have to be added together. So when we add -1 plus a -5, we get -6. Now we write out 41.83 times 10 to the -6 power. However, we are not done yet because the decimal is in the wrong place. It has to be right after the 4. So now we move the decimal, and now we have to add -1 to the -6, which would then give us our final answer. Next, we'll be converting 0.88888 repeated into a decimal. So first we're going to find the repeatant, and the repeatant would be the number that is being repeated, so that would be 8. Second, we would find the period, and it would be 1 because 8 is a single digit being repeated. Next, we would write out x is equal to 0.888 repeated, and we would look at the period, and because the period is 1, we would then put on top as 10x and then move the decimal 1 place to the right, and now we would have 1.8888 repeated. And we would solve this, so we would get 9x is equal to 1.7 because all the 8's are then canceling out. And now we would divide 9 by both sides, and we would get x equals 1.7 over 9. Now this is wrong because we cannot have a decimal place in the numerator place. So we would then multiply by 10, both top and bottom, and we would get 17 over 90 as our final answer. Finally, we have this last problem. If Visalia is 24 miles away and I have to get there in 20 minutes, how fast do I need to drive? So first we would take 24 miles and put it over 20 minutes. After that, we would want to find out how many miles per hour. So we would take 60 minutes over 1 hour. This will then cancel out minutes over 60 minutes and 20 minutes. So now we would just do multiplication across, and we would get 1,440 over 20. After dividing this, we would then reach the final answer of getting 72 miles per hour.